Hello everyone, welcome to 群主大人 Midnight Coding Diary Season 1, Episode 10, I guess. Yeah, Episode 10, yeah. Uh, okay. Today we are going to bring to you the part which topic is about the probability sampling and the randomizations. This part. Actually just like give all the coding, like how to implement the algorithms professor taught it before, right? It's really simple and easy, so I just like do it quickly. It has 6 problems. Hopefully I can do it within an hour. First is perfect shuffle. That is really easy, just like previously the digital in the class. It's like shuffling is all about the permutation. It's all about permutation, and it's just one single permutation. So it's way easier than the previous problem we did for the permutation, all permutations. So how to implement that? I can just like first check about the format. Okay, so as you can see, the problem is giving an array of integers, like shuffled array, such that all the permutations are equally likely to be generated. So how to do that? First, we have an array, and we have to do randomly generate something, right? So first, for the sanity test, like if array equals to, oh, the set is now, right? Then array balance equals to 0, then we simply like do nothing, so simply return, I guess, right? For the other conditions, we do a for loop. We do a for loop from equals to 0, I less than array.length I plus plus. Okay, and in this for loop, first we randomly. Okay, we can do this outside. It's called random equals to new random. So we create we create an object, a random type object, and the reference is random. So every time we random dot, it's not get next, it's got next int, right? Every time we get a next int from what? So that is a key part. That is a key part. Let's just like simply draw a form, a quick note about that. Let's see, we have 0, 1, 2, 3, 4. Let's see, we have all 5 numbers. We need to randomly shuffle this 5 number. So the first one, so the first one we want is a number that within 0 to 4, right? So in this case, the first time we need to randomly generate a length of from 0 to 4. So so we need to like do it 5, right? So as teacher told you before, if we do the next int 5, so this means from 0 to 5. The left is include and the right is not include. This is not inclusive, right? So in this case, we can generate the 0 to 4. And in this for loop, actually, this is considering that the array length is 1, 2, 3, 4, 5. So actually, this is just I. Yep. So this I, we at the first one, we generate I equals to 5. So we get a random number from 0 to 4. And what do next? We create the index equals to this, and then what to do is just like swap that, swap array I and the index, and of course we need to quickly write the swap function here to make this available. So it's an int array named array int I int j and int temp equals to array I equals to array j and array j equals to temp. Okay, we finished that. So, and the main part is this right. Okay, let's check for the second one. Let's see if we want I equals to 1 at this step. The index that we want to switch to that is generated from 1, 2, 3, 4, right? So this 4 index is from 1 to 4 to 5 actually. 5 is not inclusive and 1 is inclusive. That is when I equals to 1. Previously we said when I equals to 0, we need to generate an 0 to 5, right? And we can do it another one, just like do it more. How to say? When right here, when I equals to 2, we want index from 2 to 5. So we can see actually, how to say, this is from 0 to 3 and plus I. You know what I mean? If I equals to 2, then we should generate an from 0 to 3 and then we plus I equals to 2. So this becomes 2 to the 5. So how do we change from that? The 0 to 3 actually is the array length minus I. Array length is 5. I equals to 2. So 5 equals 2 equals to 3, and 3 is what we want here. So let's change the code here. So this should be array.length equal minus I and plus I outside. Okay, so this is all the code. Simply and easy, right? I don't know if this picture will help you, but the main part is how we get the index, how we get the index from, I mean, for example, if I equals to 1, then we should get from 1 to 5. Then how to get 1 to 5 actually is from 0 to 4 and we plus 1. I mean, right and left plus 1. So that's all this code. I just like first delete all the ugly nodes and then try it on the light code to see if it works. Okay, where is my light code? Here it is. Okay. Here, shuffling. Okay, just like check it. If equals to 0, return. Actually, this is not very important. Random.getNext array.length minus I plus I index, and we switch I and index. And that's all. I guess it's right. Probably. Return void, public. Okay. Check it. Okay, cool. So we come to the second problem. It's called reverse reservoir sampling. Considering an unlimited flow of data elements, how do you sample one element from this flow? That is called like the string, right? Sampling string or data string. I don't know the English meaning of that, but you know, I mean, please just like stop this video and use 1 minute to understand, trying to understand all the description of this problem, and we can, so that we can do that without any confuse, right? The main problem is that once we come into a once we read into a new value, is this value be the sample value? I mean, how much probability will this be the sampling one, the lucky guy? How much probability will this be the lucky guy? And that's the key part. Actually, it's really not that hard. Let's just change the format very quick. No. Remove space. Okay, cool. And change the format very quick. I don't need you. Okay. So first is all about this solution. Is as you can see for the basic structure of that, there are three things you need to do. The first one is this is the constructor method, right? Once you use this constructor method, you create a new object, and once you create that, all the things, I mean, within the object, all the fields should be ready, and you can multiple times use read and sample things. The read is simply we read a new value, and we should decide it if we keep this value or we keep the previous sample value. And the sample function is just simply return the lucky guy, the sample one we want. So let's do that. First, let's think about like what we just think about how how many fields we need. First, we really need a sample, right? I just call it integer. It's not int, it's integer, simply because if it's now, I mean, the default should be now. So if we read nothing, the sample should be now. I guess it's set here. Sample return at any time of the sample if n value have been read. The probability of returning any. You may need to. They didn't say that, but I guess it should be now, right? Because it's default return now. Okay, never mind. Oh yeah, and of course the return type is integer. That means the sample, which is the return, which is the field that we return, should be an integer. Yeah, that's cool. And here is every time when we created a new object, we use the constructor method, and then it should be simply like this dot sample, or not this, just sample. Sample equals to now. Okay, easy. And then another thing is we need a count. We int that count. We just need a count. The count is where you store how many numbers you already read inside this whole object. So whenever you want that, equals to 0, right? And do we need any other things? I guess not, right? So this is how you initialize the two fields of that. Every time you constructor an object, you have the initial value. One is now and one is 0. And every time you read an value, we first check if the sample equals to now, right? If the sample equals to now, then we do not need to consider any other things, just the sample equals to value, and that's all. Else, what else? Else is if we already have something inside the sample, then we need to calculate a probability. Oh, I know what I'm missing. There should be an random type named random, and here we should random equals to new random. Yep. Every time when I read an value, it should come up with a probability that we use the current value to instead to replace the already sample value. And how can we do that? It's just we can use the random to generate the count. What did that mean? That means, just like draw a little picture. For example, if we already have a value, if you already read 3 values, for example, 1, 2, 3, this is the array that, or this is the box that we already read, and in this place the count equals to 3, right? And in this one we already have a sample. For example, the sample equals to 1. Okay, and at this time when we read another one, when we read a 4, they should come up with a probability that 4 become the sample. I mean, if we read 4, then there should be two things happened. For first, sample equals to 4, and the second one is sample still be 3, right? So there should be 2 probabilities. Which one is? As you can see, it's really easy to, in this example, it's really easy that it should be like 4. I mean, 1/4 of the probability that a sample should be 4, and the rest of them is the 3/4 of the probability that the sample still be 3. Right? So how do we come up with this one? The key is use the random method. In this case, the count still be 3, right? So we first add here, I guess. First, we need to use count ++. So in this case, the count is equal. I mean, the count has increased by 1. So in this situation, the whole box turns into 1, 2, 3, 4, and the count equals to 4. So the count is 4. We use random count to generate a thing from 0 to 4, right? So that is 1, 2, 0, 1, 2, 3. There should be 4 candidates that, if we use random count, we should come up with 4 candidates that one of each is 1 minus 4, right? And here is the tricky things. We use here equals to 0. What does this mean? That means we have 4 candidates, and if the candidates just, I mean, if the random count just come up with 0, that means it have the 1/4 of the probability. Then that is the that is the case that the sample need to switch to 4. Or if the random count not equals to 0, we just keep the original sample. We do not change anything. I mean, that's all the key part of this problem, right? So we just like quickly clean all of them and finish that. If equals to 0, then what should we do? We use sample equals to value, right? Or actually we can combine them together, or random count. Oh, it's not the random count, it's random the next int count equals to 0. We use sample equals to value. Yeah. And that's all. For this one, if sample equals to now, or no, we just like simply return sample without any change. I mean, if sample equals to now, I can just return sample is now, and if it have anything inside the sample, we just return the sample. So all this code is here, clean and clear, I guess. Okay, let's double check that. Int count now 0, random read count plus plus. Now random count equals to 0, sample equals to value. Okay. Please, yes. So what are we now? Next, random 7 using random 5. That is really easy. I mean, you already have like 3 times teacher taught in the class, so I just like quickly do the implementation. Okay. Just find another one. I need to delete that. Okay, we don't need you guys. And we want to do the format, and we wanna remove space. Okay, here we go. First, the description is given a random generator random 5 to return value of random 5 is 0 to 4 with equal probability. Use random 5 to implement random 7. Yes. So what do we do now? Is use there should be like how to use that. Wait a second. I guess. Oh yeah. We need this guys. Sorry, we need this guy. Write your solution here. You can use random 5.random5 for generating. Yep. So how do we do that? First, we int a number. Number equals to random 5.random5. I can ignore this. I can't stand 5 times of that, and plus the random 5.random5. This should come up with a number that within the 0 to 24. And if the number is less than 21, that means it's within the 0 to 20. Then what we do is return name. What did this mean? How to say it in English? Percentage? Never mind. By 7, right? And What if it's not? What if it's not that? So we need to. I mean, what if this is the number is not within is not less than 21? In this case, we need to do a while loop. While loop true to let it do itself multiple times. And yep, a little bit. Yep, so that it can be seen. So this is all the code, simple and clear. I guess nothing wrong with that. Come on, baby. While true, int num random 5 5 5 random 5 something. Okay. So there's the fours. Oh, this is like really easy. It's just changes for loop while true. All right. Well, true, and we use a for loop. I need to change the format. Gosh. I need to change the format. For int I equals to, how is it like, you need 1000, right? So we have to say 5 times, I mean 5 it's not sum, plus, it's multiple, yeah. 5 multiple 5 multiple 5 multiple 5 equals to 3125, right? And this is how we dealing with 1000. So I just like simply describe about that. If we have 5, we simply have 5, we have 1 2 4, but the target is 1000, right? We need to equally, we can generate, we want to generate the thing that cover at least 1000. So we can 25 we can is less than 1000, then 125 is still not, then is 605, right? 625 is still not, then is 5555 is 3125. You can see it's finally cover 1000. So within that, you can see maximum you can have 3000. 3000 is just like the previous case. The previous case we have 25, and we use the only 21 of them. This is we have 3125. We use 3000 of that. So what we do is 27. We use the 27 divided by 7, and this one is divide. It's not divide. It's percentage by 1000. Okay, right? Am I doing anything wrong? Wait a second. Supposed to be right. Yeah. Yep. Here we go. For int I equals to 0, I less than 5, I plus plus. We create int I equals to 0. Inside that line random 5 random 5. This should be equals num plus 5, num multiple 5 plus this. Yep. And then after the for loop, we need to judge if the number is less than 3000. and we should return name. Found it. Cool. Well, this is the fourth problem. Well, true. Name equals to 0. Name equals to multiple 5 plus random 5. Name less than 3,000, right? Okay, we finished. Almost done. Oh, no. The fifth problem, I think, is the most difficult part. Okay, here we go. Medium tracker. Medium tracker is to track about, every time you plus in a thing and you add something to that, and you want to get the median anytime, in any case, you want to get the median immediately in just simple one step. So is the basic outlook is look like that. You have a solution, you have a constructor, and you simply can read that, right? You read this means you put something inside the whole group, and then the API median is just whenever you want to get the median, you just call the median. And we can see a little bit about the algorithm here. There should be a picture. What? Where is the picture? Q for follow-up. Oh, here. So the data structure is we use a max heap and a min heap, right? And the key part is the property. The key part. Okay. Within the property, we have some requirements. Actually, is first requirement is the smaller half and the larger half have roughly the same size. They have two circumstances. Yeah, there are two circumstances that is available. The first one is the size of the smaller half is equal to the size of the larger half, or the size of the smaller half is equal to the size of the larger half plus 1. That's the only two circumstances that is available or that is valid. Whenever it's not valid in this, whenever it's not valid within these two, you need to make a change. You need to switch that to make sure that finally it comes to be one of these two circumstances. And the second one is the max of the smaller half always less than equal to the mean of the larger half. And whenever you get the median, you should check the whole array, like how the side of the whole array. If the side is even, that means you use this function to get the median. Or if it's odd, just like max of the smaller half. This is really important. You need to remember that. And this is how we use to implement this problem. So we can see, as a previous, I need to check, remove, and do some stupid things. Okay. This one, delete this one, delete this one. No use of it. So as you can see, just draw a simple map here. We have we have a min heap. I want to do it this way. This is the whole array. It's let's just like assume it's a solid array, and all the median is actually at the middle of that, right? For example, if we have like 1, 2, 2, 3, 4, 5, 6, 9, 10. Okay, so the median is 4. like said at the algorithm, the property, we have a smaller half. We have a smaller half. We have a larger half. We want a smaller half is bigger or equal to the larger half, right? In this case, and also the smaller half is max heap. So the max heap, the first element of the max heap must be the biggest one in the max heap, right? So whenever the inside order is what, the first one must be 4, and you can see the rest of them are like listed here: 3, 2, 2, 1, and the larger half is the min heap. That means the first element must be the smallest within all the things. So it's 5, 6, 9, 10. Okay. So let's say in this circumstances is an available circumstances. First, the 4. I mean, there are two. There are two requirements. The first is smaller half, larger half have roughly the same size. This size 5, this size 4. So this is the B condition, right? And the second, the max smaller half is less than equal to the mean of the larger half. That means the 4 is less than equal to 5, right? That is correct. So it's an available circumstances. So what if in this case we add a number? What if we add a number? For example, if we read a 1, right? What if we read a 1? In this case, we check if 1, we check the how big or small the 1 with the 4. If it's smaller than 4, that means we need to put it into the smaller half, right? Because the structure of the min heap, whenever we put 1 inside, it should be like do some inside the inside operations. Then the 1 should be listed here, right? The 1 should finally go to this place. And then, is this an available condition? We need to check the two things. First, 4 is less than or equal to 5, right? That is correct. But the smaller half, the size is now the size is 6, and the larger half size is 4. That is not any of the two circumstances we want. So in this case, we want to do a swap. How to swap? Just simply put the 4 out and inside that one. So that means the larger half turns to be 4, 5, 6, 9, 10. And the smaller half is 3, 2, 2, 1, 1. Okay. In this case, the size is 2. The size is both 5, so is the condition A, and 3 is also less than 4. So that is correct. Or like if we want a 8 inside, for example, if we want an 8 inside, so at that condition, you need to add an 8 here, and an 8 here. The 4 is here. 4 is here. 4 is not here. At that circumstances, the size is 5. Size is 5. Size is 5. So this is match, right? If we want to add another like 9 here, then we add a 9 here, and the size turns to be 6. If the size is 6 and the current size is 5, then it's not a valid condition. In this case, we need to put this 5. We pull out the 5 and offer into the smaller half. At that case, the smaller half size equals to 6, and this reduced to 5, and it's available. Just really simple and easy. I know the picture is ugly, but I guess you know what I mean. So here we go. We want what? We want a min heap and max heap, right? So it's priority queue integer, right? Integer. because we read an int, right? So we just put an integer here. So this one we want it to be min heap. Oh no, max heap. Max heap is the smaller half. This is called smaller half. That's easy to remember. And the priority queue integer larger half, smaller half. Okay. And we also need an count, right? So the solution, every time when we create an object, we want the smaller half equals to new priority queue. Okay, and the larger half equals, no, smaller half should be the max heap. Max heap, we need to like collections the reverse order. Okay. This one is new priority queue. Okay, that one is the min heap, so we do not change anything. And count equals 0. Right. Whenever we read in a value, we just simply add it into I guess we just simply add it into the smaller half. No. We need to first check if smaller half dot is empty. Dot is empty is true, then we want to simply add it into that. So it's smaller half dot offer the value in, right? Else if we do a judgment, if the smaller half dot peak, it's just peak, it's not peak first. If peak is greater, or we can say it this way, if the value is less than smaller half dot peak, then what should we do? I really can't ignore that, right? Then what should we do? We simply smaller half dot offer. Actually, we can combine them together. So, yeah. Else, what can we do? It's larger half dot offer value, right? Simple and easy, right? And then whenever we get the median, oh yeah, we need to do the count plus plus. Whenever we do that, we need to check if count if it's an even, we need to return. That is the tricky part, because we want to return a double side. So we want to, and we store all the value is an int value. So we store all the int value inside. So we need to first do a cast. We need to cast the integer into the double. So what we do now is smaller half the pool. We do that double. Actually, we should just do that double plus plus double larger half the pool, right? Else I think I should add another, like if smaller half is empty, then we simply return now. We do that, else we return smaller half down. So it's an integer. I don't know if we need to cast it into double, just like in case do that. Okay. Do we finish all the things? Actually not. Why is that? Because whenever we read it inside that, we push it into here, but we didn't check the availability. We didn't check if this is a valid circumstances, right? So what we do now is simply do a random check function here. What is the check function? Private void check. We need to check the size. If there are two circumstances that is not valid, if like the first is larger half, the size is bigger than the smaller. Smaller half the size, then what we should do, we should get out one thing from the from the larger half, that is one thing, and we add this into the smaller one, smaller half the offer, right? With the first circumstance, else if smaller half the size is larger than larger half the size plus 1. Then what should we do? Larger half the offer, smaller half the pool. Smaller half the pool. Okay, that's all. That's all we need for these problems. Really simple and easy, right? Okay. Let's check this out. Count 3 fields. Initiate a field, smaller, larger, count 0, count plus plus. So actually the count is not used, right? I mean, it's useless. Let's see if we can delete that. So the only thing we use is here. So we can see if smaller half the size is equal to smaller half is equal to larger half the size. Right? In this case, the medium is two things combined divided by 2. Or we just like pull this one. If half size select 2 size, smaller offer, larger pool. I'll see if, okay. I guess this is good. Please. Oh, I didn't delete that. My bad. Still not 12. Smaller is empty or value smaller dot peak. What do you mean now pointer exception? Less than smaller half dot peak. if it's empty, true. No, no way. I mean, if it's empty, smaller half that peak. No way is behind that, right? If it's empty. Interesting. Let's see what I did before. Empty peak offer. I didn't do anything wrong, right? Half is empty. Larger half, smaller half. No difference. Why this time is not right? Smaller half the peak. Smaller half is empty. Smaller peak, smaller half offer. Larger half offer. What the hell? There must be something wrong here. Right there. I don't know why I don't know what happened. I just perhaps it's this part. Size. No way. Did I use pull? I used pick. Just like, okay, this is no difference, right? I'm sorry, my bad. I just don't know what part is wrong. As you can see, I mean, first this is accepted, okay, and this part is just same as what I did before. I don't know. Probably this part is an error. Probably this part an error, or probably just some error. But it's just like it's not. I mean, the 12 line is right. Anyway, okay, it's a bad experience and 95 percentile. This is still easy and clear, simple and clear. We wanna the maximum is 4096. So the tricky part is the maximum length is 4096. And it's from 0 to 4096. So if you want to create an array, you need to do like database, just like db equals to new int. Here is 4097. So you need to count on the 0, right? And here is an integer list length, right? So it's like for integer URL, or it should be URL length. We can just like length this. We just how to say int db length plus, and that's all. And after that, we do another for loop for int I equals to 0, I less than equal to 4096, I plus plus. We in the counter equals to 0. Count at n equal to dbi, and every time we make a judgment, if count, that is like 95%, right? Refers to change count to double. If double count minus the length is the length. This is length or size. I guess it's length, right? Weight n equal to 0.95. Then we return I. I guess we can do and return -1. That means unavailable. Okay. Problem solved. Let's go check that. db length plus count 0, count double count length. Okay. Cannot find symbol. Perhaps this one? I should turn to size, right? -96. It appears again. Oh, my bad. It's less than equal to, greater than equal to 95. Okay, cool. So this is all the 6 problems. It's really simple and easy. Maybe the probably difficult part, the main difficult part is how you can implement it from the algorithm or from the theory into the code. And that is what I'm providing you to implement that. As you can see, all the codes are really simple and easy. It's really the key. The core thing is how you can understand that and implement it. So that's all. Thank you for watching. Have a good day, guys.